In every factory, in every data center, there's this mountain of data being generated every single second. And honestly, most of it just sits there, like a silent record of the past. But what if you could turn that data into an engine for action? Well, today, we're going to show you exactly how to do that.
So let's kick things off with a problem that pretty much everyone faces: energy costs. If you look at a typical data center, about half the power goes to the IT equipment. Yeah, that makes sense. But check out that second biggest slice. A staggering 37% of all that energy is spent just on cooling. That is a massive operational cost, and it's basically hiding in plain sight.
So how do we even measure this? Well, the industry has a key metric called power usage effectiveness, or PUE for short. It's actually a really simple ratio. You just take the total power your facility draws and divide it by the power that's actually being used by the IT gear. Now, a perfect score is a 1.0. That means zero waste. Anything higher than that tells you just how much you're spending on overhead, like, you guessed it, all that cooling. And here's the reality check. So many facilities are running with a PUE of 2.0, which is just considered average. But think about what that means. For every single dollar you spend powering a server, you're throwing another dollar away completely on overhead. It's literally like paying for 2 meals and only eating 1. So this brings up the million-dollar question. How on earth do you fix an inefficiency you can't even see?
The answer, my friends, starts with understanding the tools you probably already have. It all comes down to knowing the difference between the data you need for right now and the data you need, well, for forever. Let's break down the 2 critical systems that handle all this information.
Okay, so first up, you've got your SCADA systems. The best way to think about this is like your car's dashboard. It gives the operator real-time control, it shows what's happening second by second to keep things running safely, but it usually only holds onto that data for a few hours, maybe a couple of days. Then you have the historian. Now this is like the car's black box recorder. It stores everything forever at super high resolution, so engineers can go back and do these really deep investigations later on.
And that quote right there really gets to the core of it, doesn't it? SCADA is all about control and safety. It's absolutely essential for the now. But the historian? That's for understanding and optimization. It's the tool that lets you learn from your past to build a smarter, more efficient future. You really, truly need both.
Okay, so we've established that we have all this amazing long-term data sitting in our historian. Where do we even start? Well, the great news is you don't need a team of PhD data scientists to find your first big win. I'm telling you, there is gold hiding in the data you're already collecting.
In fact, you would be absolutely amazed at what you can find with just some simple tools. So often, just one well-designed chart is all it takes to reveal a massive opportunity for improvement that was totally invisible before. You just got to know where to look. Take a super common problem like downtime. By pulling data from your historian and making a simple Pareto chart like this one, you can instantly see what's causing the most pain. I mean, look at this. It is so obvious that sensor faults and process alarms are the biggest culprits. So instead of guessing, your team now knows exactly where to focus their efforts.
And this same data-first approach, it works wonders for energy savings. Let's circle back to our data center example and check out a quick case study to see this exact principle in action.
So a research team took a look at a data center, and they found its PUE was 2.04. And as we just talked about, that is firmly in the average, or let's be real, the inefficient category. That is a lot of wasted energy and money. But then, by analyzing the historical temperature and airflow data, they found some super simple optimizations. Things like adding blanking panels and just rearranging racks to stop hot and cold air from mixing. And the result? The PUE dropped all the way to 1.92. I mean, that change represents a huge reduction in wasted energy. And they did it without buying a single new piece of equipment. And that is the key takeaway here. The answers to some of your most expensive problems are probably already sitting right there in your historian. The first and most important step is to simply look at it, visualize it, and let it tell you its story.
Simple charts are incredibly powerful, for sure. But what about the problems that are just too complex or too subtle for the human eye to catch? This is where we level up and bring in the AI watchtower.
See, we humans are pretty good at spotting big, obvious spikes on a trend line, but what we really struggle with are those slow, creeping changes, those tiny, complex interactions happening across hundreds of different sensors that might be signaling an impending failure. That, my friends, is a perfect job for a machine.
So how does this actually work? Well, it's surprisingly straightforward. First, you take an AI model and you train it on months of your normal historical data. The AI basically learns the intricate digital fingerprint of your healthy operation. Then you just let it watch the live data feed. The moment a pattern emerges that doesn't match that fingerprint, it flags it as an anomaly, often days or even weeks before a standard alarm would ever dream of going off.
And I want to be super clear. This is not some far-off future technology. This is happening right now. You can go on open platforms like Hugging Face today and find powerful pre-built models and code examples for this kind of anomaly detection. This tech is more accessible than it has ever been.
Now, finding an anomaly early is great, but that's only half the battle, right? The final, and honestly most powerful step, is turning that AI-driven insight into an immediate, automated action. It's time to close the loop.
Okay, so here's how this awesome automated loop works. First, the AI model, which is just watching everything all the time, flags a subtle deviation from normal operations.
But a raw data alert from a sensor isn't very helpful by itself. So here's the magic step. That alert is automatically sent to a large language model, which translates all that complex data into a simple, human-readable explanation of what's going on. And finally, that plain language explanation gets instantly sent to the right person through a workflow tool like Slack or email. It delivers not just an alert, but actual, actionable insight right where they need it, when they need it.
And that is the new workflow in a nutshell. Data flows from the historian to an AI detector. An LLM translates it into plain English, and an automated system notifies the right people. This entire process, from just a subtle flutter in the data to an informed human taking action, can happen in a matter of seconds. It's a game changer.
You know, this really gets to the heart of the matter. We have to stop thinking of our data as just some backward-looking record of events. It's a living resource. It's a constant stream of lessons that can be used for continuous learning and optimization.
From a simple chart that saves thousands of dollars on energy to an AI that prevents a catastrophic failure, the potential is already there, stored away in your systems. So this really just leaves us with one question. Your data is talking. Are you listening?